Alright, so we're going to do lesson number 2A and 2B. Those are the two lessons for geometry. We got Sarah in the house. You have to verbally respond. We got Rick Dog.
Hello.
Also known as Big Rick. And we got Sam.
Hello.
He doesn't have a nickname. Alright, anyhow.
We'll get there.
Yes, everyone turn to page 24 in your book. We're going to do circles and then we're going to do trig. Alright, so the first topic is circles. This is a pretty exciting topic to teach, I think, because the trick is very, very simple. So the first thing that you show them is what's the equation of a circle. They call it x minus h squared y minus k. I tell them I don't like having these numbers either, so I'll usually just do x minus something. If I write out the formula, I would say x minus something squared plus y minus something squared. And then I say, well, what's that? Equals the radius squared. Well, what's that something? Oh, that something's the center coordinate of the circle. And then I'll say, so for example, if the coordinate of the center is the point 3, 4, then it would be x minus 3, y minus 4. Well, let's say that the center coordinate was 2, 1. What would it be? And everyone could say that. Oh, well, let's say it was negative 2, 3. And then they'll tell you, oh, well, then it would be x plus 2, right? Y minus 3. So then you say, okay, fine. So now, let's say I told you that I have an equation like this. X plus 2 squared, y plus 7 squared. Well, tell me, what is the center coordinates? Negative 2. You understand? So you can work them into being able to see that. You take them step by step. Fine. So that's very simple. And then this one will give you a chance to see where, okay, if you know that the center coordinates are 3, -1, and you go pick out the one that has the 3, -1. It's this one here, and it's also this one here, right? These two just have completely different center coordinates. And then, well, what's the radius? The radius is 4. This one is a big radius. So you say it's always going to be the smaller one. This, by the way, if you counted, it would have a radius maybe of 16 or something like that, or maybe the whole thing would be 16. So that's the point here. Good? Everyone good with that? Mm-hmm. All right, fine. Very basic. The next thing is you see this kind of equation and you say, in order to normally do this, how you would ordinarily do it, you would have to do completing the square, right? So I'll say I'm going to teach you how to do completing the square. Actually, maybe I would even start with completing the square, I'm not sure, and then I would teach the trick. Maybe I would do that. So I would say we have this equation here, and the problem is that there's a number next to the x. When we looked at that formula, there wasn't a number next to the x, so how do we do it now? We do completing the square. You take the middle term, divide it by 2 and square it, so you would have x squared plus 6x plus 9, and you also add that 9 that you add to one side, you add to the other side. So now the 23 also gets plus 9. Then you would do the same thing with this one, so you would get y squared minus 4y plus 4, and you also add the 4 to this side. Then you factor these, and what you should always get is one thing times itself. One thing times itself. And then same story over here. Y minus 2, y minus 2. And then if we had to clean this whole thing up one more time, you would have x plus 3 squared plus y minus 2 squared equals 23 plus 4 is 27 plus 9 is 36. Now if you look at the coordinates, you would see that the x is -3, the y is 2, and some of them may mistakenly pick 3, right? But then it is actually 6. The radius is 6. The radius squared is 36. And what I say now is look actually at this trick that we could have done in lieu of completing the square. It won't always work. It'll always get you the right answer if you could do it, but it won't give you the radius. So you take the middle term, the 6, you just divide it by 2 and change the sign. So you get -3. Divide it by 2, change the sign, +2. Then which radius should I pick? You pick the smaller radius. The bigger one is the radius squared. So that's out. This is the answer. And that trick will always work. That's a cool, exciting thing you could show them. So now doing the next one like that, you could see that that one's going to work also. So this one though, they ask you, so then on the next one you would say, on this one though, they ask for the radius. Now which two radiuses could I eliminate right away? Well, I could actually eliminate the 25 and the 16. How do I know that I could eliminate those? Those are radius squareds because the square root of 25 is 5 and the square root of 16 is 4. So those two are the radius squared options. And that's why those are not the correct answers. So that's something cool maybe that you could show them also that would be exciting. So now how do I actually figure out what it is though? Well, you would divide 4 by 2 and square it. That's plus 4 you would add to this side. Divide negative 6 by 2 and square it. That would be plus 9 you would add to this side. You would add that 12 over to the other side and you would have 12, 16, 9 is 25 and the square root of that would be 35. So we say always look at the choices. You can learn so much about the question just by looking at the choices. Okay, the next one here, again, you could easily do this one. So the one next to the y, if we take it and divide it by 2, it becomes negative 3. Right, so right away we eliminate these two choices. And then, again, smaller radius, choice 2. So maybe 14 should actually be before the other one where you need to do completing the square. But that's 14. This one they just ask you where you made a mistake. I'm sure you're all able to figure that out. And then this is just more work in case that they really are not capable of doing completing the square and you want just more drilling work, you have it here. But you don't need to use it. If it feels like they have the hang of it, then I think you're sufficient. 23 is the one that's a little bit different, so I guess it's worthwhile to look at this one because it looks a little different than the others. The graph below shows AB, which is a chord of circle O. Let me just make this full screen. It makes more sense. Oh, it doesn't help me though. That's why I don't have it. Right. So those are the endpoints. The distance from the midpoint of AB to the center of the circle. So you have this line. And the distance from the midpoint of AB, which what is the midpoint of AB? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 5. 1, 2, 3, 4, 5. So right here, you don't even need the midpoint formula. The distance from this to the center of the circle is 2 units. So then I guess you would just check all the centers. The point 1, comma, negative 2, 1, comma, negative 2. That one clears out. Choice 2 is negative 5, comma, 2. That doesn't seem like that. Does that work? Doesn't work. Is that the answer? Which could be the correct. Oh, this one so far. Okay, fine. Which one's not correct? 3 would be 1, comma 2, 1, comma 1, 2. That one doesn't seem like that would work. And choice 4, 5, comma negative 2. That doesn't seem like it would work either. So is that it? One's the right answer?
Why doesn't 5
Well, yeah, why doesn't 5? That should work.
Oh, 5 should also work?
We just don't know which way.
1, 2, 3, 4, 5. Oh, okay, so 5 would be the point, you're saying this one. 1, 2, 3, 4, 5, and negative 2, 1, 2.
Yeah.
Oh, so that one would also work. Okay, good. So we're between these two. What other info did they give us about it? Anything?
Yeah, I wasn't sure.
I think it's kind of.
Does that have anything to do with the chord? Because it's a chord.
AB is a chord, so
AB has to be in the circle. So I would imagine. Okay, so what are our two options? Let's write them out. We have the point 5, comma, negative 2, this point here.
So it has to be 1, not 4.
And we have this one here, 1, comma, negative 2 right here. So they're both the same. So I would think that it has to be the bigger one because, yeah, the radius of this one here is 5, so the diameter would be 10. But this stick is already 10. And if it's not directly in the center of the circle, it's going to protrude out of the circle. Whereas this one is one that's slightly bigger than 10, the diameter, right? The square root of 29 will give you 6. We'll give you 5, right? A little higher, and then, so that's the answer. The higher diameter. Good?
So why was it the larger diameter? Because then
Because this is a
it would
chord
be
and
exact.
the length is
It would
10.
be it would be a
It
diameter.
would have to be the length of the diameter it would protrude.
If it was
because it's
25.
mass, right.
Right.
That is the actual, right. Alright, good? Fine, but that one definitely could be a little bit tricky, so I'm glad we did that one. Alright, fine. So that one, if you have a fast group, then you hit them with that. Okay. This stuff is really basic, but I ran into a group where they didn't understand this stuff, so then I designed this slide and whatever. So what does circumference mean? So I just first explained it's perimeter just in a circle. So for example, you have this shape here. Let's say I wanted to fence it off, and they should all be able to understand, oh, okay, so then this side would be 12, this would be 10, and I would just add up the distance on the outside. Well, we call this perimeter in a rectangle, but in a circle, that's circumference. So giving them a understanding of what it is important, not just memorizing the formula. And then you would tell them that you do it by using the diameter. It's pi times the diameter, that's the equation, okay? I really literally have to explain this slowly, so that's why I have the slides there. Do I give an example that they should do? No, I guess it's pretty simple. Oh, I have it right here, okay. So now here are all the examples for them to try. So, what is the circumference of an object with diameter 20? Okay, 20 data, right? Okay. And are we trying to build this? The radius is 50, teaching them to convert to 2 times the radius, right? That's 100. In after, I don't imagine we'll need this, and maybe other schools we may. The circumference, okay, now working backwards. The circumference is this. What is the radius? So I gave 2 tricks here first. So that this could be pi d equals 314.159. They might have a hard time with that. It's possible for people to have a hard time with that. Divide by pi, that's also hard. You just say pi is just a number. So to divide by, it's not such a complicated idea. You should get 100, okay.
The radius is
and then the radius should be 50, good, yes. Then this one, a designer needs to, this is the way that it's asked on the test, which is even harder, but designer needs to create a circular necklace. The radiuses are 10, what's the largest number you can make? So first you find out the circumference of it, so it's 20 pi each one. And then you say, well, if you have 1,000 pieces of wire, you divide the amount of wire you have by the amount of wire it's going to take. And you get a decimal. I think it's a 15 point something high decimal, right?
Yeah,
it's 15.
but it's around down.
Right, exactly. So what is it, 15.8?
0.9.
0.9, and then you got to round down because if you don't have enough to make the necklace, you can't make the necklace, okay? This question, the next one's visual. They have a very hard time. All you need to realize is that this represents the circumference. They just took all the pieces and it just
Half.
half. Oh, right, because yes,
Two sides, yeah.
because this would be one and that would be the other, right? So half of the circumference, good. So then you have radius of 5, fine. So then you would just do pi times 10, and then you would divide that by 2, and that would get you the answer.
16.
Mm-hmm.
Okay, good. All right, so that's basic. Area, same idea. What is
Does
the
this
area?
take long, to teach these things? Like how
It shouldn't
quick
take
do you
it,
move through
depending
these
on
things?
depending on who you're teaching. It's possible that they won't know how to do this. It is,
Right.
but it's also possible that they'll know how to do this in a second.
Okay.
Yeah. Was the area of a circle with radius kind of like 100 pi, right? Pi r squared. Was the area diameter? Okay, 5. I mean, either it's very simple for them, or you need this because this is really here just as an aid for those that really struggle with this. And then working backwards again. So I have the area 144 pi equals pi r squared, and then divide by pi. The pi's go away, square root both sides. R equals 12, and diameter then is 24. Okay, so that's that. What is the population density of a circle with a population of 200 and a radius of 6? So population density is just how many people there are over how much space there is. So right now there's 4 of us in this room, so it's 4 people per room, right? If there was 100 of us in the room, it would be 100 people per room. And if you want to know per foot, you put foot on the bottom. It's population over area. So a circle with population 200, radius of 6, so you would say 200 over the area, which is pi 6 squared. Okay, it came up maybe once or twice. I don't know if this is something that they plan to ask. It came up once, I don't know. So then this is the example of the question. So here you have 51, half of it would be 25.5, right? 25.5 square is the radius, so pi this, 40,000 over that. And then you would do the other one, which is 72,000 over pi 75 squared, and I don't know which one is more dense. It looks to me like B is more dense, yeah.
So you got B?
You could also, I guess, you could also set up a proportion.
No, A is more dense.
You got that A is more dense.
Yeah, 19.58 for A and 16.23 for B.
16 point.
No, that was 19.58.
19.58 and 16.23.
23.
This is you, and you did this?
Yeah.
Okay. Sarah, you did that too?
Yeah, I didn't get that.
Well, it's not 75 squared, it's 37.5 squared.
Oh, good point.
Maybe I made a mistake.
I might have made that mistake, Sam.
I don't know. We'll find something. I have that answer for you briefly.
Yeah, it's definitely B.
Yeah, okay, so it's B. Alright, cool. On
I
to the
mean, it's
next.
A, sorry.
It's A is the more dense one.
A has, yeah,
Okay.
greater population density.
Oh, yes, I agree.
Yeah, you wrote that.
Yeah.
Okay, fine. Alright, next one. So this is the first level. The formula that I used to say was that radius times radians equals arc length. But what I noticed is that the way that they always give it on the test is they don't give you the radius and the radians looking for arc length. They give you the arc length and they're looking for the radians. So instead, what I think the better formula to have is just this guy divided by this guy. Arc length divided by radius gives you radians. So that's just the easier way to think of it. So it would be 2 pi over 10. And then that would be pi over 5. Very simple. Right. Next one, again, 144 pi over 6. Next one here, pi over 4, 13 pi over 8 over 6.5. And which one's bigger in that case?
Circle 2.
Circle 2. Okay, next.
I got that they were equal.
Oh, shoot. They are equal, sorry.
They are equal.
Yeah.
They both end up
Dominate
being
is
pi
correct.
over
Yeah,
4.
yeah,
Yeah.
0.78.
Okay, fine. Good. Okay, for this next one here,
This is hard for them now.
no, so this is just, I kind of inserted this idea here as a way of them learning what arc length and what arc measure is. So it's worth talking about. What we were just talking about before, we were saying that the arc measure, right, in this question here, before, we were giving I'm just blabbering, okay. So let's look at it. Arc length measures the distance. So A, like circumference, and AC measures the arc. This AC arc length measures the proportion. So for example, if diameter AB is equal to 10, what is arc length AC equal to? Arc length
Do you mean?
AB.
Yeah.
AB equal to. Yeah. So you would just do circumference of the whole thing, right? And you would get 2, pi d. Okay, so you get 10 pi. And then you divide it by 2 because you have half of it. That would give you the arc length. The arc measure would just be 180 because it's half of the circle. Okay, so that's something I never knew. I never understood why they were telling me that the arc was a certain size. How do you know how big it is? It's not saying how big it is, it's giving it as a proportion out of the circle. So that's something I just wanted to explain there. So over here, AOC, what is arc measure, if arc measure AC equals 110? Okay, so now, once they give you the arc measure, not the arc length, the arc measure, you're able to figure out this size of the angle. So if this AC arc measure is 110, then this angle is also equal to 110. Okay? If this arc measure here is 90, then this angle here is 45. This is called the inscribed angle. This is called the central angle. Good? Clear? Okay, fine. So that's very basic. So now, when we get to this next example, they tell you that EC is tangent to the circle at BC. So we didn't say this out loud, but tangent, that actually is not relevant here. That's why, okay, it doesn't matter. EA is tangent, also doesn't matter. They tell us angle CDA is 50, and they want to know what's arc measure CA, so it would be 100. Okay, so that should be very, very simple. Looking at the next one, they tell you again that the angle's 24. Which angle is 24? Angle ABC. If this one's 24, then what's arc AC equal to?
Oh, they're asking
48. And if this is 48, then what's the angle? Also 48, yeah. Or you could realize that, and you do need to know this, that these have a 2-to-1 ratio. That's going to be the next question. So, right? The ratio of angle ABC, the arc AC. So it's 1 to 2. The smaller one, they weren't mean enough to put 2 to 1 anyway, so just 1 to 2. Okay, good. That's nice of them at least. Okay, the next one, same thing. Okay, very simple. Fine, so let's leave it, yeah. Okay, cool. Now, there's two 90-degree angles in a triangle at any given time. There's inscribed angles to diameters and tangents and diameters. This is an important topic. So this is the idea. If you ever see a diameter, right? So we have this diameter here, okay? What we know is that how big is arc AB, arc measure AB? What is that measure equal to?
180.
Right, we know that it's equal to 180. And if it's equal to 180, then how big is angle C? Half of that, so that's going to be 90, okay? Now, it's hard for them to see for some reason. You'll see that the diameter opens up to the diameter. It's that this angle here cuts open half the circle. I'm not sure, maybe you could see if you find a way to explain that very simply. Tangent in the diameter, the rule is just if a tangent hits a diameter, the angle they form is a right angle. So those are two right angles, and you need to be able to identify both of those right angles in triangles at any given time. And 21 will really test to see if you understand that. So it looks like some of the words are cut off, but bottom line is tangent. So let's look at the angles. Angle AOB, angle AOB. Oh, so he says an angle inscribed in a semicircle is a right angle. So AOB, that's not a right angle. I mean, maybe it is, but it's not because of that. BAC, that's opening up to this small arc, not half the circle. That's not a right angle. DCB, that one is opening up and cutting the diameter. So that one is the inscribed angle. Now FDB is also a right angle, but that's a right angle for a different reason, not because it's inscribed. Good? Okay, now, fine. The other point I would just make is just use your eyes also. Like, you could clearly see that BAC is not a right angle. So these things, they're always drawn to scale. Always drawn to scale. You could always tell them that. That's just like a fun trick to show them. They get a little excited. Okay? So now, okay. We have, which statement is not always true? ACB is equal to BCD. Okay, I'm not sure about that one. ABC, that's a right angle, inscribed by the diameter, equal to ACD, that's a right angle, that's out. BAC, DCB, okay, also hard. CBA and AEC are both right angles, so those are eliminated. Okay, so that's most what I want them to get out of it. Now, to get more, I said for choice 3, 90 minus BCA gives you both angles, so let's see why that's true. BAC, how is that 90 minus?
I think I meant for choice 1.
For choice 1 I meant?
Yeah.
Let's see. ACB. Right, good, he's right. Angle ACB, what's that angle equal to? It's equal to 90, this is 90, minus angle ACB, right? Would give, minus angle BCD, so not BCA. And then BCD, no, that would be 90 minus BCA.
Yeah.
ACB would
I
be 90
think the
minus.
answer is 1.
Not always true. No, so then that's not what I meant. Then I gotta look at 3. BAC. Oh, this is why. There's 3 angles. It is 3. There's 3 angles in this triangle. This 90-degree angle. this angle and this angle, how many, so there's 90 degrees left in this triangle to be split by this angle here, BAC, and this angle. So this angle here, angle BAC, is equal to, angle BAC is equal to 90 minus angle BCA. Understand? And on choice, and DCB is also equal to 90 degrees minus angle BCA. So that's what angles are equal
So
to.
BCA
I
is
finally figured
shared.
that, I wrote it.
BCA is shared by both.
Something like that.
What's that called?
I don't-
When you're doing a proof, what's it called? When the same piece is in both. Subtraction
Something
partially.
like that. I don't plan for them to get this right unless it's a very advanced group. I would just say I just want you to eliminate those two. Oh, yeah. Oh, yeah. I knew I had that helpful note scribbled down.
So I don't get the note really, but
So, this angle,
no.
this angle is equal to 90 degrees minus this angle.
Same names. Angle.
Well,
Okay.
and
Angle
then-
A equals 90
And
degrees.
But this should be
this
for,
angle,
this should be for choice
BCD,
one.
is also equal to 90 degrees. Now, this is why this is true.
BCD equals 90 minus.
Okay, I'll give you an example and then everything will make sense. Let's say I told you, I just came out and told you that angle BCA equals 30 degrees, okay? What does angle BAC equal then?
Oh, gotcha.
Right, they're both
60.
60.
What does DCB equal? Also 60.
Because that's right angle, those two are right angles, and that angle is shared. Gotcha.
Yeah. Okay, that's what they call me beast mode. Alright.
Relax.
Alright, this sometimes I notice some people having challenges with the area, the part of the area of the whole equals angle, the part of the angle of the whole. It's not a complex formula, I'm not sure why people struggle with it. So you have, they tell you that the area of the shaded sector is,
I think that got cut off.
Yeah, it could be one.
It just doesn't make sense.
alright, but let's say it's 1, big deal.
Okay.
It's 1.
The numbers
alright?
are just so
Yeah,
weird.
it's cut
Yeah.
off. It'll be weird. Let's say it's 10.
Yeah.
Let's say
There
it's
we go.
10. So then you whatever you want. If you don't remember, then they could still do it. So the rule would be that the same percentage that this piece has to the whole circle, this angle has to 360.
They're in
So
proportion.
they're in proportion. So you would say, okay, the area of the piece is 10 and the area of the whole circle is 36 pi. Well then the angle is x and the total circle is 360. And then you just solve.
Mm-hmm.
So you would get 100 over pi.
Yeah.
Would get you whatever that is. 100 over pi would be the area of, would be the angle, right? Not in radian. Okay. So now this one will be similar. What is the area of the sector with radius 8? So now they want the area. We're going other way. So the area of the whole thing is pi 64, 8 squared. 60 over 360 x. And that's it. Sometimes it can be challenging. I put it last in here.
And what's the easiest way to tell them with the solving with the pi when it comes to problems like these?
I put a decimal form.
Like leave it. You don't have to be using the pi button because it
option. So if they, right, so I don't care if they use the pi button, then put all these on the calculator also, whatever's easier for them.
Okay.
If they say, oh, I have a decimal and to know what do I do? Okay, so just take all these choices, put them on the calculator and see which one gets
Because
the
when you
same
solve this
decimal.
one out, you get 10.66.
Right,
Which
okay.
is just 32 over 3.
Right, so you're gonna have to put this on the calculator anyway, unless you're doing it. If you ever put it on the calculator, then
I'm saying because you see pi's in all the tabs, can't you just take the pi off the top and the pi with the bottom off?
you could do that too, yeah.
So just head
Yeah.
of it's right, whatever. Okay, fine.
Okay. The next one here, AC. Yeah, this is 20 degrees. What do they want to know? Find the area of sector BOD. So if this is 20 degrees, you have to do a little, 180 minus 20 is 160 divided by 2 comes out to 80. So these two are 80. And then now it's just the same thing. 80 over 360 equals x over 36 pi, exactly, pi r squared. And then just put it on a calculator. Almost done with circles, almost. A couple of challenging questions here at the end. So this one's tricky. They tell you that OH is 6 and that FH equals OG. and OG is also 6 because it's a radius. So then this guy's 6 also, and this guy's 6 also. This is now an equilateral. Every angle is 60 degrees. So now that we know angle, this is 60 degrees. It's 60 over 360 equals x over 36 pi. Yeah.
Mhm.
It's a little fast. That's could be a hard question. Just
Is there, it's
rewatch what I
radii.
said.
Mm-hmm.
Okay, yeah.
And then this last one here, NL is 6. Angle N, they want to know, and they said that the area of this is 2 pi. So first you got to find this angle. So you say 2 pi over 36 pi
Over 9
equals
pi,
x.
Because 6 divided by 2.
Oh, 6 is the diameter?
Yeah.
Okay, good. Over 9 pi equals x over 360. You find x, and then you got to divide x by 2 to give you n, because this is the, what did you get for x the first time?
It's 80.
So if you saw
Central
the,
angle
right,
is
so
80.
you saw the central angle is either, it could be, there's a couple that it could be because of the choices. Definitely not 80, right? So 80 divided by 2 then is the 40, and that's why those choices are
Cross
there.
out 80 and 20.
Just 8, not even 20 though, because 40 and 20.
Oh, wow.
So they string you down the whole thing. Okay. And then random circle facts. One is just to notice the alternate interior. So angle BCD is 30. What's angle AOB? Well, you know this one's 30. And then I guess the other fact is that
They were both radii, so it's isosceles.
this is true. So this is 32, and then if this is 30, then you get that one. Or I was thinking that some form of that. And then that's a really color. Okay. And then for 15, the idea is just that in a circle, this is 110, this is 70, this is 72, this is 108.
Wait, how do we get that?
So it's just a rule. The reason that the rule works is if you look at it, this arc is 1. That's this guy's half of that arc, and this guy, the D, is half of this arc, and together, what do they make up? 360. So therefore, the two angles add up to 180. But you don't have to.
Vertical
really see
angles
that.
add up to 180.
Opposite.
Opposite angles in a
Yeah.
circle. Yeah.
Okay.
Any four-sided
And then they
shape.
gave one more question.
Mhm.
Hold there. All right, fine. So that's that. Let's just pause it before Trey